बैग किसके लिए?
Yes, it's good to speak to somebody like that, but you're correct, my brother is happy. Yeah, because he calls me idiot, I call him a dumb idiot. So it's a relationship.
That particular
It's inside of the game. It's so pretty. That's very special.
Trisha,
Yeah, why is she not come?
he's in the school, I guess.
Why? Why? Do you miss her?
I think to collect her brother's TC
Do you miss her?
per day.
Do you miss? Why? You're her best friend now.
She's my sister.
Shai's sister or best friend?
Sister.
Now
I know her from nursery.
Okay, so best friend sister. You know what sister is? I don't know what he was saying. I was saying, okay, brother. I didn't understand what he was saying. I was trying to think, but I couldn't. He was saying something, I couldn't understand what he was saying. Then randomly, my brother is going to know. Yeah, and he's also. No. Yeah, he's in my British class. But he used to be nicer. Right now he's very mean. He used to be nicer when he was young. I don't know what happened, but he's not. Does she want to hug? Sure. SND24. What is this? Not trying to hug. You should hug. You are something else.
सीधे मना चाहिए चलिए अरे लास्ट में हम लोग पाउच लेकर तो सीन हो गया था।
मैम
परी अपने ओरिजिनल जगह पे आ गया।
मैम परी तो अपने ओरिजिनल प्लेस पे आ गया।
परी तो अपने जगह पे
मैम शुभम
मैं बाद में फिर बात
वो वहाँ बैठेगा वो इधर आके डाल दिया अरे रखा तो रिजेक्ट
क्या ये सब ग्रुप है
ये
रिस्पेक्ट क्या है पनिशमेंट रिस्पेक्ट वो ये
त्रिशा ये
नोटबुक में छेगा
ये पेन है
You exhibit pleasures from others.
परी बुक किधर फेंका भाई जो मैंने पेन फेंका है
Fast. So we are going to start with refraction of light. कितने बच्चे बाहर हैं अभी? अभी रेखा मैडम सबको पनिश करने वाली है। लेट आ रहे हैं। तो any idea what is refraction of light? पढ़ा है छोटी क्लास में?
जब लाइट ऑफ
Bending of light when?
when the light enters lower medium to denser
Lower नहीं, rarer denser होता है। Okay. Everybody is in? Okay. Let's start. So pay attention. What is refraction of light? Refraction of light is whenever light enters from one transparent medium to the other transparent medium, its direction changes in the second medium. This phenomenon is called refraction of light. Okay? We'll understand it with the help of a diagram. Suppose this is the boundary of two mediums. Say this is the first medium, generally air. And second medium, let us say water or glass layer. Okay? So air is a rarer medium. What rarer? Optically rarer. Okay, glass is a optically denser medium. So we don't write optically. You just mean that when it is denser, it is optically denser. What is the meaning of optically rarer and optically denser? Light travels faster in optically rarer medium than in optically denser medium. मतलब glass में speed of light will be less. Speed of light is maximum in air or vacuum. And what is the speed of light in air and vacuum? V into 10 raised to 8 meter per second. Have you studied it? So speed of light in vacuum or air is this much. Okay, and this is the fastest speed with which any physical quantity can travel. In universe, nobody can travel faster than light. Is that clear? Okay. So what I was saying, what is refraction of light? Whenever light travels from one transparent medium, that is air in this case, to the other transparent medium, its direction will change in the second medium. What was its original direction? This was its direction. So it is not going in the original direction, but it is changed. This phenomenon is called refraction of light. Okay. Now, what are the consequences of refraction of light? there are many consequences which you might have observed. Let us say there is a bucket full of water. Put a stick in it. Okay? Stick. You will see that the stick is bent. The portion of stick which is inside water, it will be bent. Have you seen that?
Yes, sir.
Or if you enter in the swimming pool, so somebody watches you from outside, he will feel that your height has become less. The portion which is inside the water becomes small, shrinks. Okay, so all this is what your size is whatever it was. Okay, but when you come out, you look normal. But when you enter in the water, you get dwarfed. Okay, so these are the phenomena due to refraction of light. Why it happens, or you can check when you go in your home, take a bowl, okay, place a coin, right, in the bowl. Now you're seeing that the coin is kept in the bowl or in a cup also, right? Now you raise the cup such that the edge of the cup now blocks the view of the coin. You understood what I'm saying? कप के अंदर कॉइन रखा, अभी ये दिख रहा है, ठीक है? अब कप उठाना शुरू किया तो उसका एज आ जाएगा ना आई साइड में, कॉइन दिखना बंद हो जाएगा। तो वहीं तक कप उठाना है जब तक कि कॉइन दिखना बंद हो जाए, और फिर उसमें वाटर डालो। जैसे ही वाटर डालोगे फिर कॉइन दिखने लगेगा। आई बात समझ में? तो क्या हो रहा है, वाटर से जैसे ही रे बाहर निकली बेंड होगी तुम्हारी तरफ। समझ में आया? हाँ, ये है। So refraction of light has many applications. The depth of the swimming pool looks shallower than it actually is. And therefore, you may get disguised and might be tempted to take a jump in a swimming pool. And if you don't know swimming, you might sink. So, if you look at any water body, it looks shallower than the actual depth. It is due to refraction of light. बाहर आके उसका बेंडिंग होने की वजह से तुम्हें लगता है कि जो पॉइंट यहाँ पे है वो तुम्हें यहाँ दिखाई देने लगता है। समझ में आया? इतना लेवल रेज अप हो गया ड्यू टू रिफ्रैक्शन ऑफ लाइट। Got it? So it is important that we become familiar with this phenomena to understand few physical phenomena. Okay. So now, what is this angle? This is called angle of incidence. This is angle of refraction. What is this surface? This is the boundary separating the two mediums, air and glass. This could be water also. Okay. So let's call this as PQ. And this is AO, NO and dash. Right? So during refraction of light, this is our reference diagram. So what is AO? Incident ray. Then OB is refracted ray. Reflection of light is over. That phenomena is over. Now we are studying refraction. Reflection was light was bouncing back in the same medium, but refraction it is entering into next medium. That's the difference. And when the light is entering the next medium, its direction actually changes. So this is refraction of light. So it is refracted ray. What is NON? Normal. Where is normal? On the surface PQ. So this is boundary separating the two mediums. Okay. So is this clear? What is refraction of light? And there is a rule. Whenever light enters the denser medium, it bends towards normal. And whenever light enters rarer medium, let's say if the light was from here, like in torch. So there is a glass layer. When the light comes out, it spreads. Okay. So when it enters denser medium, it bends towards normal. When it enters from denser to rarer, it bends away from normal. So these are the rules you have to remember. Now let us understand what is laws of refraction. Just like laws of reflection, you have two laws of refraction. One is common. Common is the incident ray. Okay, we didn't write what is AO. Written. The incident ray. The incident ray. The refracted ray. Yes. And the normal. At the point of incidence. Lie in the same plane. The incident ray, the refracted ray, the normal at the point of incidence lie in the same plane. Alright, now the second law says sine of I upon sine of R is equal to constant. Okay, this is called Snell's law. क्या exchange चल रहा है? Seat change किया इसका? Why have you exchanged the seats?
Sir, because this was my place and he was sitting on my place.
नाम लेकर के आओ.
नहीं सर साइड
मैडम ने
हाँ वैसे ही साइड
I was not aware of it. Okay, sine of I upon sine of R is constant. Everybody understand what is sine I? Sine हाँ क्या लगा था? I के ऊपर डॉट नहीं दिख रहा? I है I ये I है लिख ले जैसे. Okay, so what is this constant? Where the constant is called the refractive index of second medium with respect to the first medium. कांस्टेंट का भी एक नाम दिया हुआ है. क्या नाम है? रिफ्रैक्टिव इंडेक्स ऑफ द सेकंड मीडियम with respect to the first medium and is written as n/1 or 1 and 2. So therefore n/1 is equal to sin I by sin R. ओके कांस्टेंट को कैसे लिखते हैं n/1 और पढ़ते कैसे हैं ये लिखो so this is a new thing for you so what is I is angle of incidence and R is angle of refraction.
So I do not understand Snell's law.
I'll tell you. First, write it down, then I'll explain. Is the monitor visible to you?
Yes.
Yes.
Everybody can see what is written here.
Yes.
You can see? देखो तो अलग से पूछना पड़ता है. Let me know what you have written. I'll explain what is Snell's law.
Then so still
When everyone.
एक पूरा लिखा
नहीं लिखा है ना?
जो जी बीच में को आधा गलत लिखा है उसमें आ जाए सर
चलो.
देखा वो पहला पॉइंट दिखा
बस एक बार ही पूछना पड़ेगा.
मैंने स्टार्ट भी नहीं किया.
अरे लिखा है ये ऐड होएगा ऐड क्या होता है सर गलत
दिखा
At the
देना.
point of
नोटबुक दिखा नोटबुक.
इस बॉक्स का ये सीक्वेंस कटिंग है देखिए
so at the point of incidence तो ये
डायग्राम किधर है?
डायग्राम
ये बनाना था.
बगैर इसके कैसे लिखेंगे? This is related to this.
मार रहा है
एक मिनट देखो कैसे बना.
थोड़ा अनऑफिशियल है बात में
अनऑफिशियल. पूरा उल्टा डायग्राम बनाया है. रॉन्ग.
वो बोला अनऑफिशियल ऑफिशियल बात
ये जो इंसिडेंट रे है पूरा टेंसर मीडियम में रे दूर चला गया. कैसे बनाएंगे? इसका मीनिंग है देखो ये सब ये तुम्हारा घर का स्केच बुक नहीं है. यहाँ मीनिंग है अगर तुम्हारा नॉर्मल से ये एंगल बन रहा है तो टेंसर मीडियम में एंगल छोटा होना चाहिए. सब दिख रहा है मेरे को.
जो आज
सर कोई चीज क्या होगा? आपन देखिए.
सबने साइन कर दिया?
हाँ सर.
दृश्य और राजीव सक्सेना
so Trisha is absent. No, the one with the
सिस्टर.
Yes. तुम क्या करोगे सानी की किसकी सिस्टर है?
Where is that?
अभी कर रहे हैं.
Cousin.
लेंस लो जानने में इंटरेस्ट नहीं है तेरे को.
पता नहीं
और
बस.
कौन क्या है ये जानने में बहुत इंटरेस्ट है. डायग्राम ठीक है. ये वाला डॉटेड वाला किसी ने डायग्राम से नहीं बनाया. रिजॉल्व डायग्राम को लिखा है इसको.
I did not realize.
नहीं वहाँ कुछ नहीं. Listen, this diagram is important. इसके बगैर इसका कोई मीनिंग नहीं है. साइन आई कहाँ पे है डायग्राम में? ठीक है. लिख लिया सबने? Draw it with the diagram. Yes, correct. डायग्राम बना तो मुझे मालूम पड़ेगा ये सही बनाया कि गलत बनाया. ठीक है लेकिन वो पहले लिखना चाहिए. डायग्राम पहले. जिस सीक्वेंस में मैं लिख रहा हूँ ना और हर चीज लिखनी है तुमको जो मैं बोर्ड पे लिख रहा हूँ. क्या नहीं दिख रहा है? इसलिए मैंने पूछा मॉनिटर दिख रहा है कि नहीं. मैं सामने खड़ा हूँ तो मॉनिटर पे देखेगा. डॉटेड वो स्ट्रेट लाइन. ये डॉटेड है ओरिजिनल डायरेक्शन. ठीक है. सिर्फ एक बंदे ने गलत डायग्राम बनाया और वो है ये.
ऑलवेज डिफरेंट
Always different. ठीक है चलो. Should I explain what is Snell's law?
This is just
Label the diagram correctly. This is angle of incidence. AON, angle of incidence. BON dash is angle of refraction. थोड़ा मैं पहले इसको समझाने की कोशिश कर रहा था बट लाइलाज लाइलाज मालूम है no treatment disease is without treatment ला इलाज बोलते हैं उसको जिसका ट्रीटमेंट नहीं होता ना उसको बोलते हैं ला इलाज Smart enough to guess. You have to tell you. तो वैसे भी
अलग है ना इससे
Okay, you're taking too much time in writing. Everybody done? Raise your hand. जिसने नहीं लिखा, raise your hand. Is it writing towards normal? Yes, little bit. So it is correct. Whenever the light is entering into a denser medium, it has to bend towards the right now. No. During reflection of light, write this down. During refraction of light, the light ray bends towards normal. When it enters from rarer to denser medium.
They're laughing and disturbing.
You focus on your writing. When it enters from rarer to denser medium and vice versa. Okay, what does it mean? During refraction of light, whenever light enters from rarer to denser medium, it bends towards normal and vice versa. What is the meaning of vice versa? Yes, opposite. When it enters from denser to rarer, it will go away from normal. Bend away from normal हो जाएगा. Towards. Writing done?
No, sir.
The only concept to be understood in this topic is this only. If you understand this, everything else just follows. ये and vice versa. Now let me go a little deeper. This is a single color light. Single color. When I say incident ray, it is of, pay attention here, it is of single color. It is also called monochromatic. What is it called? Monochromatic. Okay. So this law, Snell's law, is valid when a monochromatic ray enters from one transparent medium to the other transparent medium, and this ratio is always constant. Now what is this ratio? this, when you take sine of this angle, you can measure this angle, and then you can write down, let us say this was 45 or 60 degree, let us say it was 60 degree, right? And let us say you get R as 45. So whatever answer you get, for a given pair of medium, this value will be constant for all angles. Meaning, let's say this is I1, this is R1. So I got some X value. Now if I change the angle, let us say I increase the angle of incidence to I2, then this refracted ray angle also will change in same proportion, such that now sine sine I2 upon sine R2, this will be same as sine I1 upon sine R1. You understand this?
Yes, sir.
So this ratio is always maintained for a given pair of mediums in a light of single color. Got it? So that's why this is written as constant. And this constant we read as, how this constant is read? Refractive index of second medium with respect to first medium. Okay? How do we read this constant as? Refractive index of second medium with respect to first medium. Is it clear so far? Okay. Now let us go ahead. So this we will write as N21, and this is constant for a given pair of medium. What is the pair of medium here?
Sir, air and glass.
Air and glass. So if you would have taken water and glass, then it will be a different value, but it will be same for all angles.
So what would be more denser in water and glass?
Huh?
What would be more dense
Diamond. The table is given.
as compared to water and glass?
That's what I'm saying. Diamond. There is a table given. Why are you laughing?
No, I was inquiring if when we compare water and glass, as you said, which one would be denser? You said diamond.
Oh, I thought you were asking what medium is denser than both water and glass. Between water and glass, obviously glass.
Glass is alright. Water.
Where is the table?
The page number 26.
26 you have, the refractive indexes of various substances. You need to remember for water it is 1.33. 26. For water it is 1.33. This ratio of sin I by sin R is 1.33. And for glass it is 1.5. These you have to remember. And for air it is 1. Air is the reference.
Where glass fits.
Glass होगा ना?
Ground glass.
Ground glass is 1.5. There is flint glass also.
What's the difference? Ground
Flint glass is a toughened glass, more denser than crown glass. The ordinary window glass is crown glass, and a protected glass is flint. So these are different types of glass. Okay, so we'll come to this table later. I just wanted to tell you that this has got some value. Now, what is the physical significance of that? What is the meaning of refractive index of any substance? Okay, can I erase this side?
Yes,
There is another definition of refractive index. Refractive index तो हमने क्या बोला है रिफ्रैक्टिव इंडेक्स हमेशा किसका होता है सेकंड मीडियम का होता है ऑफ द सेकंड मीडियम विद रिस्पेक्ट टू फर्स्ट मीडियम ऑफ द सेकंड मीडियम Acha, second medium, how do we define second medium? Second medium is the medium in which light gets refracted, where its direction is changed. If light was traveling from here to here, then what is the second medium? Air. Okay, so it depends. So you have incident medium and refracting medium. It is also classified like this. Incident medium, जहाँ पे angle of incident बन, and R is refracting medium. Is that clear? Okay. So refractive index of the second
The
medium.
second
that
medium
is
is
refracting medium. Yes. The second medium is for a given pair of medium. And monochromatic ray is also defined as ratio of speed of light in the first medium to the speed of light in the second medium. This is the second definition of refractive index of light. So therefore, that is N21 is equal to V1 upon V2. So V1 is speed of light in the first medium and V2 is speed of light in second medium. Where
इधर लग रहा है
नहीं नहीं बेटी नहीं लग रहा
इधर लग रहा है
Sir, can you please turn off one
नहीं चल रहा
My God, it's very hot. It's 40.
nowadays
अरे थोड़ा सा यूज हो रहा है थोड़ा सा बीच में क्या चल रहा है अरे क्यों
okay, so speed of light in first medium versus speed of light in second medium. So question, why the directional path of light ray changes in the second medium? So far we told you that this happens. Now the question is, why it happens? You'll understand that. So what is the reason for refraction of light? Written? Should I explain?
just a minute
Speed of light is represented as c, right?
Yes, only in vacuum or air. So we have, if the first medium is air, then V1 will become C. I've given you C as speed of light in vacuum or air is C. So, what is the answer to this question? Why the direction of path of light ray changes in the second medium?
So because speed of light is different in different mediums.
Yes, so it reduces. So therefore, it was traveling so fast, but the moment it comes here, it slows down. So when it slows down, it went towards north. But here, in this direction, it travels here and suddenly it increases. Then it goes away from north. Is that clear? What was so amusing? Yeah. So if it is traveling from rarer to denser, since it slows down, that's why it closes towards north. And here, since it travels fast in the rarer medium, यहाँ से आते आते fast हो जाएगा, वो दूर चला जाएगा. Clear? So this is why. So you can say the answer is due to difference in the speeds of light in different mediums. This is the reason. ठीक है, स्पीड अलग अलग है इसलिए डायरेक्शन चेंज होता है. तो फिर रिफ्रैक्टिव इंडेक्स क्या है? रिफ्रैक्टिव इंडेक्स क्या बताएगा? अभी समझो ये एयर है और ये ग्लास है, तो स्पीड ऑफ लाइट इन ग्लास इज इक्वल टू V1 by N21 हो जाएगा. तो रिफ्रैक्टिव इंडेक्स इज द फैक्टर by which the speed of light changes in the denser medium. ठीक है ना? तो रिफ्रैक्टिव इंडेक्स खाली फैक्टर है कि कितने फैक्टर से स्पीड ऑफ लाइट चेंज होता है अदर मीडियम. समझ आई बात? तो ये कॉन्सेप्ट है बेसिकली. So therefore, refractive index, RI means refractive index, is the factor by which the speed of light changes in the second medium. ठीक है? यहाँ से क्या हो जाएगा? V2 is equal to V1 by N21. ये refractive index is the factor with which speed of light changes in the second medium. V1 तो maximum है, maximum speed कितनी है? 3 into 10 raised to 8. ठीक है? ये होगा. So having understood what is refraction and laws of refraction, now we'll understand some relations, some important relations involving refractive index of light. Just shuffle yourself left, right. Look at the monitor when you can't see the board. Okay, now are we good till here?
Yes.
Yes.
Can I erase the upper part? I need this diagram then. Okay, let me erase this. Okay. So we'll write down some more formulas for refractive indexes. So देखो, if you have now since N21 is equal to sine of I upon sine of R.
Sir, here also you have to draw the diagram.
Better. Or don't draw, it's okay. You can follow the same diagram. Okay.
Okay.
Now since N21 is sine I by sine R. क्या हो गया? अच्छा, तेरी आंखों से वो देख लेगा क्या इधर देख. N21 is equal to sin I by sin R. ठीक है? तो अभी हम इसको रीअरेंज करेंगे. So this is equal to 1 upon sin R upon sin I. ठीक है? अब देखो sin R मतलब अगर लाइट रे तुम्हारी यहाँ से ट्रेवल कर रही हो, ये डायरेक्शन को हमने उल्टा कर दिया. लेट अस से if the direction of light is changed from second to first medium, तो क्या हो जाएगा? अब sin R by sin I को हम क्या लिख सकते हैं? N12 ऐसा लिख सकते हैं? Where N12 is equal to sin R by sin I. ठीक है? ये लिख सकते हैं ना? तो ये एक रिलेशन मिला. N21 can be written as 1 by N12. रेसिप्रोकल के टाइम पे मीडियम क्या हो जाएगा? स्वैप हो जाएगा. Is that clear?
Yes.
मतलब direction change now. N12 is from, that's why I am taking using this diagram when the path of light is reversed.
So why is it written as N21? What is that?
That's how we define no refractive index. कैसे define किया था? Refractive index of the second medium. जब light ये direction में चल रही है, तो second medium क्या है?
The second medium.
जिसमें angle of refraction बन रहा है, ठीक है? लेकिन समझो मैंने ये लाइट का डायरेक्शन उल्टा कर दिया. यही केस के लिए डायरेक्शन उल्टा कर दिया. तो अब क्या हो जाएगा? Angle of incidence is equal to R and angle of refraction is equal to I. So what is I and what is R? तो अब ये क्या बनेगा? Second medium is जो पहले first medium था अब क्या हो गया? Second medium. जो पहले second था अब क्या हो गया? First हो गया. इसलिए उल्टा होगा. Same refraction का जो law है, Snell's law, for denser to rarer medium, it becomes sin R by sin I. Understood?
Yes.
Second, is, so this is first. This was first, okay? First case. Second is absolute refractive index. What is absolute refractive index? When the incident medium is first medium. Incident medium, that is first medium, is air or vacuum. Then refractive index of refracting medium that is second medium is called as its absolute refractive index. Okay, and is written as that is N21 is equal to C by B and is just written as N2. Right? So when the first medium is air, that time the refractive index is, the first medium is not mentioned. N21 becomes just N2. Is it sinking in?
Not really.
So can I explain this?
Write it first.
My terms are all mushing together now.
Yeah, I know. This is the reason this chapter needs to be done. Now you say electricity is difficult.
The numericals are.
Okay, we'll see when we reach there.
Our school said electricity is the most difficult chapter.
Can you live without electricity for a second? How can it be so difficult? We learned about electricity 200 years ago, even before, 400 years ago. We are living with electricity since then. After fire and wheel, the next thing was electricity. You are a computer age boy, digital. Are you real or virtual? Huh? I feel you are an AI product. Whenever I look at it, I feel this AI. Humanoid. Is artificial intelligence. Huh? That's why I said, right? Artificial intelligence.
Artificial.
Just artificial. Just artificial.
I'm not saying superficial.
Sir, देखा था अपना तो artificial ही.
Actually,
क्या वो तो विश्व की theory माया
ऐसा है ना, ये सब relative है, relative.
वही तो मैं कह रहा हूँ सर नॉट की ड्रीम में है.
बाप रे
What's
Listen, this is a class of physics and we will not divert.
कौन सा philosophical YouTube channel देखता है?
Bring him back into mainstream.
हमें काम में तमिलनाडु से लेकर वहाँ पे दिख जाएगा. तमिलनाडु ये बताएगा.
रंगनाथ टेम्पल में गया था क्या? रंगनाथ कौन है पता है? वही लॉर्ड विष्णु. Okay, anyway. So what was I telling? Absolute refractive index. What is absolute? When do we say a refractive index as absolute? जब पहला medium air या फिर vacuum. बस as simple as that. देखो. तो इसको हम ऐसे भी लिख देते हैं. कभी-कभी N21 की बजाय we can write it as dA by dG. NGA, refractive index of, listen everybody, it's going to give you real pain if you don't understand it now.
What happened?
Bear with me. Why? You have a bottle of milk with you? What happened? Look here. NGA, refractive index of glass with respect to air, is equal to velocity in air, velocity of light in air divided by velocity of light in glass. Okay, leave the bottle behind. Okay. So what is absolute refractive index? NG. So when I say NG, when I'm not mentioning the first medium, listen, when I'm not mentioning the first medium, the refractive index is absolute refractive index. And now what is VA? C. And velocity of glass, either write VG or just V. Understood? Understood? 1, 2 की बजाय हम मीडियम का नाम का फर्स्ट लेटर भी दे सकते हैं, ठीक है? So this is refractive index of glass with respect to air is written as just Ng.
That is considered accurate.
That is considered as absolute. It is a convention. We are just building rules right now. When the first medium is not mentioned, you have to understand that it is air, and therefore this is its absolute.
Okay.
So whenever we call refractive index as absolute, the first medium is air, and we don't mention the first medium. That's what it means. And when you don't mention the first medium, we know that its speed is speed of light, that is c. Is that clear? Now we'll express N21 in terms of absolute refractive index. This is the last relation. Third. Okay, so what is Ng? Ng is absolute refractive index of glass with respect to air. So we don't write with respect to air. You understand that whenever it is absolute refractive index of glass, it is with respect to air. Very good. Now you get it. Okay. Third.
I can't take more information. My brain stopped processing.
And you are only in class 10. I mean, look at
Just
yourself.
storage ball.
Don't underestimate your power.
Power does not exist.
More data cannot be downloaded. Storage is full.
I'll set him on you. Okay. Expressing Ri, refractive index, in terms of absolute refractive index. Okay. Now look here. So what is N21? This is equal to V1 by V2 by the second definition. Everybody is with me? N21 is equal to V1 by V2 by the second definition of refractive index. Only two definitions. What was first? N21 is sin I by sin I. Second one is V1 by V2. Ratio of speed in the first medium to the second medium. ये था हमारा second definition. Now what we will do is we will multiply numerator and denominator by c, which is speed of light in air. So c by c. Okay, what did we do? Multiply and divide by c in numerator and denominator. Okay, so we did c by c. So now we'll rearrange. We'll write it in terms of absolute refractive index. Can we say that? Oh, this is V2. Yes. What can we write? This we can write as c upon V2 divided by
Please stop laughing.
Okay, can we do this?
Yes, sir.
Why I love
Laughing.
How did we get this step? C by V2 upon C by V1. Tell me how we got this after this. ये देखो C by V2 तो है, we just rearrange. C by V2 we wrote in numerator. देखो क्या होता है? A upon B into C upon D. How can we write it? Can we write it as A upon D divided by B upon C? Can we do this? Can we do that? That's what has been done here. ठीक है ना? You guys are ahead of time. Okay.
Yes.
So what is C by V2? What is C by V2? C by V is absolute refractive index of second medium. So this is N2. And what is C by V1? Absolute refractive index of first medium. Okay. So what formula do we get? N21 is equal to N2 by N1 final. Yeah? So this implies you might need to use all this while solving numericals. But have you understood? Everybody, right? I know this class has become a bit heavy, and we are also reaching time, right?
Yes, sir.
Why the clock is not using? Okay, so have you written till here? I'll explain in the next class. Revise, okay? Revise, and we are going to meet after 15 days. Listen. We are going to meet after 15 days. Do all the homework. Anyway, we are going to meet after 15 days. So you have 15 days to do your
Sir,
homework.
we don't have holidays.
So maybe we are from first May from morning 7:30.
We don't have
All 5 days.
every day, sir. Saturday,
Every day.
What time will reach
Sir,
home?
on first May we have classes from 7:30 to 6:15.
बता सकते हैं
आधा दिन पढ़ा सकते हैं। ठीक है, try to read also.
जो हमारे going to church. अरे मुझे पढ़नी जल्दी आ भार पैसे 10 तू नहीं आ रहा ना पार्टी आ इधर साइड में आता है सोशल एंजाइटी अबे